Hey guys, and welcome to the overview of the robot we built in the last 3 days. That ended up being about 14 hours we were live. We did just a little bit of work outside of that, but that's really about all that went into this robot. So it's designed to play this Game Changers game, and I think it ended up doing pretty well. How do you feel about it?
I'm pretty happy with it. This was my first robot in 3 days or robot in 14 hours, whatever you want to call it, that I've ever done. And yeah, I mean, I know both of us, we were really surprised at actually how much we were able to get done between Ethan, me, and Luke, and everybody behind the scenes within the past, 3 days. But I'm pretty happy with it. It's not, it's definitely not a world's level robot, especially not this year with the extended season, but I'm amazed at how far we got.
So on Monday, we kind of just sat down and talked about what our goals were for this robot and what we wanted it to do. And the thing that kept coming up was that we really just wanted to be able to show teams different ways they can use parts and how the game elements this year interact with goBILDA components and just overall robot components. So in this robot, you'll see mostly goBILDA. There's some 3D printed parts, and there's one little sheet of plastic that we cut out on a bandsaw. So it's overall a lot of goBILDA. It's really what we have and what we're all really familiar with. So that was the biggest goal, was really just to show teams how they can use parts. And we know that a lot of teams won't end up being around parts as much this year because they'll be at home doing most stuff in CAD or being socially distanced during meetings. So we felt like it was especially important this year to be able to show, get a glimpse of how things interact in the real world outside of CAD. So let's kind of start with the first thing on the bottom. We started with a Strafer Chassis V2. So that will be up, I believe, very shortly on the goBILDA website. It's a pretty nice kind of incremental improvement over the first Strafer chassis. It's faster, uses 8mm Rex shafting, and the biggest thing for us is that it allows us to use a lot of the center space of the robot. So as you can see, most of the mechanisms on the robot are actually down inside the chassis. So having the drivetrain motors in those rails really helped us a lot. The next thing kind of up on the chain is our intake. So I'll let you talk a little bit about that.
Yeah, so we talked about a bunch of different designs for intake. We were thinking about maybe even a sideways wheel intake like you'd see in Skystone or Relic Recovery or something. But we decided on this sort of triple roller, 2 top, 1 bottom style thing, where the bottom roller, if you saw in the earlier shot, is disc wheels mounted as low as possible. It's actually on beams and then a pillow block to just get it about 4 millimeters above the ground. So everything on this bot is very, very low. But the purpose of that roller is just to bump the ring up onto the rest of our intake after the front just pulls it in. And if we're ready to demonstrate it, I can just get a little bit of power going here, power up our transmitter. You can see how everything moves there. This roller and this roller are both powered off the 19.2 Yellow Jacket in there with this chain run, and then there's also round belts going up to our shooter, which we'll talk about in a bit, but that just helps carry the ring all the way up. And then for simplicity's sake, we decided to just power the bottom roller separately with this other 19.2 Yellow Jacket that is just beveled and chained down. So I'll give you a little demonstration. Turn the intake power up. Goes right up in. Grab another one, and they all just stack nicely right there in our indexer.
Yeah, so that kind of brings us nicely over to the shooter. That's something we spent pretty much all day Monday working on and trying to refine. So you can see it is a kind of a bare motor with no gearbox on it. And what's the exact ratio on that again?
The exact ratio is 1.06 to 1.
Okay, so it's just barely slower than free speed, and it's driving a 72mm gecko wheel. So that, where the other wheel over here is just a 72mm Rhino that's stationary. It's not moving at all. So we found that to be kind of the most accurate, and in our limited testing, that's what we ended up going with. So we can probably spin it up here. It does also expand as you spin it up that fast, so that's definitely something to keep in mind. And then feeding that, there's a little super speed servo down in the bottom that just flicks the bottom ring out into the flywheel.
So we're going to shoot some rings at our main camera here, and then we'll give you a close-up of our little indexer there. So
we'll switch over so you can see the nice point of view.
Spin up the flywheel.
Woo! You hit the camera.
Yeah.
So that's kind of the meat and potatoes of our robot. It goes from the intake to the indexer, those round belts, and over into the flywheel, which is what really shoots it.
Yeah.
So
can you get a good shot of that servo in there?
Yeah, let's switch
Super
over.
speed servo. You can try and move it around too. See. Yep, I'll move it around a little bit.
Yeah.
You can see it's literally just a little servo horn on there. And if you grab another ring,
you
can demonstrate a little bit of how that would go in. This way? Yeah. All right, so we'll feed that ring in there. And then
so it just
see
that all that servo does is just push it over into the shooter wheels.
Yeah.
So
that's it. Fairly simple.
It's really we also found that it really increased the kind of reliability of our shooter, because it's shooting with the kind of the same amount of force every time. That entry into the shooter wheel is really important, we think, in actually shooting these objects this year. Yeah, that's a lot of the parts that actually made their way onto the robot. So we can talk a little bit about our wobble goal mechanism. So that was something we spent probably a couple hours on yesterday, and we never actually got really nice and tuned in, so it didn't end up making its way onto the robot. But it would be mounted somewhere like this, and it has this speed servo with a linkage to extend horizontally. It just uses channel slider kits from goBILDA. And we would also have probably another servo or maybe a motor to lift this up vertically. So this allows you to lift something up, go extend over the wall, and then lift it down kind of gently, which would be pretty nice. So it also has these angle pattern mounts, which act as kind of our gripper almost for the wobble goals. So it will get in there and fits between kind of nicely underneath that rubber cap, and you could lift it up and extend it the rest of the way over the field. So something to actually grab onto that and hold it in place would be a lot nicer, I'm sure. And maybe another support for this system back here, and the ball bearing slide pack instead of a channel slider might be some ways you could improve this, as well as maybe implementing it onto a robot. But it was a fun prototype that we did, and it allows us to kind of get a feel for how these go. I don't know if I'm not sure if I would pick up by this rubber cap in an actual robot.
I mean,
it can slip off.
It's like, it's pretty good on there, but it's just one of those squishy rubber caps. So
depending on how many rings, if you're loading rings onto it or not, that would be where I would be a little worried.
Yeah.
But overall, I think it's a fairly solid design. If you had a servo to get in there and clamp down on it, that would help a lot. So first up, now let's talk a little bit about our giveaways. So the giveaways that we have today are really based on the coupon codes on our website. So you'll be able to jump in, and the first 5 customers to check out with some gecko wheels and disc wheels will get another one free. So as long as you add either of those 2 things to your cart and type in the coupon code, which is going to be in the chat for both of those things, you'll be able to get another one with your order. So those are 2 components that really made up a lot of the meat and potatoes of this robot. So that should be really fun. So you should be able to start that giveaway, and it'll paste it in the chat. You'll see all those keywords and stuff like that. Let's see. Do we have any questions from the chat, Luke?
If you go forward fast enough and suddenly stop, the jerking motion accidentally shoot a ring?
That's a really good question. We didn't really test that a whole lot. So
When we practiced, we definitely did not.
yeah,
No.
we never really were full speed and then stop, or full speed and reverse. So that's definitely something here in a few minutes. We'd like to get this over on the field and really start running it through its paces and showing you guys how this whole thing works. And that kind of brings us to the state of the robot right now. How do you feel that it is right now? If you're going to show up to an event, what would you want to change?
Stuff to change, I think, given like a decent 3 months ahead, a first event kind of thing, I think I would definitely try and put another motor on the flywheel, get a little bit better spin up time and a little bit better rapid fire capability. Right now you'll see we can pretty easily rapid fire into mid goal, but some of our angles and stuff at more normal battery voltages don't really allow us to get into the high goal very often. Unfortunately, I think if we went through, that's the other thing, is go through and really tune the shooter angle and the powers to get it in that high goal consistently, because you saw our clip from earlier in the week, we were hitting on our test jig high goals all day, like 11, 12 in a row. But obviously a lot of geometry can change when you mount it on the bot, so we know it's capable, but it just needs some tuning and we didn't have time for it. Other than that, I would probably try and add side skirts anywhere that we can. One of the things we were finding in testing is that rings can kind of just pass right under the bot, which can be an advantage and a disadvantage, because if you look at the bottom of our bot, there's a lot of stuff sticking down below the channel. So rings are soft and squishy, and they can get stuck under various little items. And
we even had a couple just get stuck under the wheel, and the robot still drives around fine, but you're controlling this ring that's just kind of stuck all the time.
Unideal.
Definitely. So just to kind of briefly go over our control system, it's all RC based and RoboClaw. So it's really great for quick and dirty testing and stuff like we're doing right now, but we definitely would go in and program it with some nice automations and other things for a final kind of real robot. So that would be a big thing to work on a lot, and we probably would have to spend a lot more time on in a finished robot.
Definitely.
I think just tuning would make a huge difference.
Absolutely.
If we really worked on getting that intake angle or shooter angle and getting the intake so it could only go where we wanted it.
And honestly, biggest thing, driver practice. Bad robot with more driver practice always beats a good one with none. So.
If we were really trying to win an event in 15 hours, we probably would have stopped at 10 at least and just practiced for every hour we could get out of it, because that helps a lot, especially when you've got every different thing to control on this robot. It can take a lot to kind of get into the flow and muscle memory of turning on the shooter on and off and turning the intake on and off as you're going through cycles. I would also like to implement some kind of wobble goal scorer. There are a lot of points, and just pushing around the wobble goals kind of sucks. So some kind of way to control them really well and put them where you want them in autonomous and in endgame, I think would be a really, really good improvement to a real full competition robot.
Yeah, and another thing would be for the ring stacks and auto, getting something that's a little bit better than just a massive gecko wheel roller to deal with that, because we haven't really tested it with a stack of rings, but I feel like the gecko wheels will just climb up the rings. But yeah, we could test that really fast actually on the table here.
Something that I believe it was Vulcan did in Rescue was they had a bar that was taller than the blocks but shorter than the balls. so they could just push balls along in front of them and only grab the blocks. I probably would do something like that for this robot.
Let's see. That is not awful.
Yeah, it's not great.
It's not good.
I don't think it would be very consistent, but
No.
it works. And another thing, I know that our bot did say you had to type in a keyword in the chat. You do not. It's just about checking out and buying those items in the goBILDA store with those coupon codes. So you don't get anything extra from saying wheel, but we really do appreciate additional followers and all of that stuff. So let's see. A big thing that improved our intake a lot was these round belts. And round belts in general were something I've not really ever used before this robot, but they kind of made a lot of sense here. So especially in that intake, they really pull the objects up into the shooter a lot more often than having something that's unpowered, and they worked out really well for that. We also are using them on our shooter to actually drive the wheel, which turned out really nice, because if you were ever in a condition where that's stalling out, you're not actually stalling your motor, and it allows you to be really, really flexible with the ratios in there.
Yeah.
So.
I see it there.
With that, do you want to put it down on the field and run some matches?
Let's do it.
All right.
Come test your driver practice.
Yeah. And then a little later on today, after we're done with all of this, we'll actually go through and show off some parts that are in development right now to making robots like this easier. One thing that we weren't super happy about was the way we are interfacing with a bare motor on the shooter. Right now it's just a bare motor with a printed adapter that goes to 12 Rex. But sometime really soon here, thinking about in like probably end of next week, we should have something that'll allow you to really easily interface with that bare motor and work with goBILDA. So I'll try to stand in about the driver's station, which is a little tough, and dig up my human player. Yeah, so the intake is probably the thing that I'm the most happy about. Let's see here.
What alliance are you?
Red.
Blue.
So intake shooting consistency is a huge thing with this game, really. There we go. There we go. Oh. Driver practice is the biggest thing that would help me, especially. Another thing we noticed about this shooter is that it tends to really shoot the last one furthest. We're not really sure why this is, but we think it's probably just because of the weight of the previous springs. That's where you can just kind of drive up on the rings and get stuck pretty easy.
Yeah, that wiring on the one side is an especially big culprit of that.
So, we are technically controlling more than we can today, but we are kind of tuned fairly well for the mid goal right now. We can hit the high goal, but without some tuning, it's not very precise.
Try rapid firing for mid goal.
So yeah, an additional motor or more weight, or both probably, would definitely help out with the rapid fire potential of a robot like this.
And let me get that ring unstuck for you.
There you go. All right. And then another thing is, I'll shoot for those power shots a little bit too. Oh. The power shots are not easy. They'll definitely take some practice getting that line up just right.
Oh. Yeah.
There we go.
We did get one to land on the
Yes.
stick of the power shot earlier.
So that'll be an interesting thing, like forum ruling, see how they rule on that. If your human player can get them unstuck. But I could even see some kind of auto aim being really helpful. The other thing is chasing rings is hard. You have to be really fast to be able to accurately chase rings this year. So having maybe an even faster drivetrain than we have here might be useful. So we are even running a 5 feet per second roughly drivetrain, and it feels slow compared to these rings.
Oh, 4?
Oh, I do have 4. That's a downside. So yeah, looks like our round belts fell off, so some way to constrain those would probably be a really good upgrade to this robot. But overall, I think I'm kind of pretty happy with how it ended up.
Yeah.
Definitely driver practice is going to be huge in this game. Standing over to the side of the field and trying to get those lineups really precise, especially for the power shots, is tough.
Mm-hmm.
Yeah. It's going to be a big driver practice game, I think, for sure. And fast robots are going to be huge. Chasing those rings is tough. But another thing is when you're using the human player return stations, they roll forever.
Yeah, here's throw me one.
Oh yeah.
That's why I was tossing them on the field earlier, because move the transmitter too.
Yeah. They will just keep rolling, so we don't have field tiles or field walls set up right now.
That one
so
even
they
rolled
keep
over
rolling
a ring.
away. Yeah, that one even rolled over another one.
And they also, the rings also can get stuck. Like, if you just roll them down, sometimes they'll just get stuck like this in the little tube. And I don't know what they're going to do about that. Maybe just have you bend this a little bit or something. But it's not easy to shove your hand down in there and get it out from the player station.
Yeah. Speaking of the field, a big shout out to Oklahoma FTC. They're lending us this field set for us to use for our robot in 3 days. So we're really, really happy that they were able to help us out with that and get us one early so we can help you guys out early. Do you want to move back over to our studio and talk a little bit more about this robot?
Sounds good.
All right. So if you were going to start over and build a new robot from scratch with a month to the competition, what do you think you'd go with a design like this?
I think what I would do is I'd probably get a little bit more shooter angle, get that ring up a little bit higher, raise the shooter up. One thing we found with our test jig, which was it was a good, 60 mil, 72 mil higher than where the shooter is mounted right now, which was actually huge, we realized later, because the rings do not arc. They actually will just keep their angle and float down. So when shooting in the high goal, that is a very small gap, and you want your ring to fly as flat as possible for the most accuracy into that goal. So that's why this sort of design would be a little bit unoptimal for that, because you need even a little bit more angle. and you guys could see it's a pretty extreme angle that the rings were flying at, even just in the field testing there. So that would probably be a big one. I think this intake is fantastic. I would probably want to either use some sort of fingered wheels, maybe even cut the flat part off of the gecko wheels for this initial part and just use the spokes, or spring this roller, something like that. Obviously, get everything down a little bit lower, but yeah,
I think it definitely turned out a lot better than I expected it to.
Me too, definitely.
It feels like with another maybe 5 hours of tuning, it could be a really solid robot. But yeah, let's talk a little bit about how we interfaced with the Bear motor and how we're planning to do that in the future. So here there's a 3D printed adapter that goes from the 17-tooth pinion gear on the motor itself over to the to basically a 12 Rex bore hyper hub. So you can clamp onto that, and it gives you a really solid way to interface with it for a 3D printed solution. Really what we'd like to do is have a dedicated part that's going to be a lot better for it. Let's see here. And I think that'll help a lot. So that's something we are working on right now, and we actually did get prototyped a little bit. Let's see, there we go. So you can see a little better here. It is an adapter to go from that 17-tooth pinion to 8mm Rex. So that has just an 8 Rex output on the Bear motor. So it's at that 66,000 RPM. And there's also an 8 Rex bearing in there. So it's bearing supported in addition to the bushing that's in the motor. And you really just need this adapter. It's a 17020032-0001, I believe. And that lets you adapt that Bear motor to the goBILDA pattern to be able to use it with pulleys and gears and a lot of our other 8 Rex components. So that's something we're really hoping to have in stock about by the end of next week. But we're really pushing to have that as fast as possible to be able to make shooters like this at this speed really possible. So that's going to be really, really exciting. How do you feel about gecko wheels as a shooter?
I like the grip a lot. They're very, very grippy. What's a 30A?
Yep.
30A durometer. I don't think I'm a huge fan of how much they expand at the RPM we're running it at. They'll expand a good like 10 mil in diameter, so they'll end up being more like 82 mil when you're shooting the ring. But I think maybe a more middle ground, where a more solid wheel at the same grippiness, not durometer, they're different. The same grippiness would be better, but honestly, for what it is, it's been great.
Something that we haven't tested until really like 20 minutes ago was adding more mass to the flywheel. That's something that I think could help a lot to shooters in general. As you get that inertia up, it wants to stay at that speed, so it should allow you to rapid fire a lot more, but it hurts your spin up time. So honestly, I would probably try to condense the intake down to 1 motor.
Yes. And
shoot with a 2 motor shooter, because I think that would help a lot with the spin up time and having enough power to really kind of power through those additional shots.
Absolutely. Also, not having the encoder cable right next to the flywheel would be a good thing.
That would be good. That was kind of a last minute addition after we did some wire management.
I'm just going to do that now.
Yeah.
Making me nervous.
That's a good idea. This really kind of was a hobble together and try to make something work to show off all of these concepts for you guys. That's just been so important to us to be able to show how these rings interact, show how you can do a transfer, because I think that might be the hardest part of this game.
Absolutely, yeah.
Maybe second to getting a really consistent shooter, but if you can get that transfer really consistent where it never breaks, I think that's huge.
Mm-hmm.
Getting something stuck, a ring stuck, can, at the best case scenario, means you can only control 2 meaningfully for the rest of the game. So that would help a lot. We'll definitely highlight these streams on Twitch, so you should be able to go back and rewatch all of the live streams of our builds throughout the season, and feel free to grab some clips and all of that and share it with your friends. And definitely reach out and ask us if you have any questions about this robot and all of that stuff. If you would like the step file for that 3D printed adapter, you can always shoot me an email to ethan@goBILDA.com, and I can send you out the step file for that adapter that we have. We've only really tested it on my personal printer, printed out of carbon fiber PETG. On our list of things was to print it out of PLA and test it there. But that may not be something we do after all, because we can get a Nitrex solution a lot faster than I was expecting us to be able to. So we should be able to have this solution really quickly, but if you're still after something that you may be able to prototype at home or get you up and running just a little bit faster, that is a pretty viable option.
One important thing to note, on this robot we are running the 3D printed part.
Mm-hmm.
We're not running the press fit 8mm Rex, so this has been holding up since Monday, which is really nice. Again, carbon fiber PETG, so
it's hard to compare to like your normal filaments, but I also don't know.
Filaments, PLA.
I'm really not sure how much stronger it is. I've not done any real stress testing. It just is kind of fun to play with. Even if it's not like really stronger, it makes me feel better.
Yeah.
But a really important thing with that print is to support that output shaft. Because you've only got one bushing in the motor, having another bearing to support that out at the end really helps a lot. I don't think that the output shafts for these motors are pretty beefy as far as 1/8 inch goes, but they are still an 1/8 inch shaft. So having some way to support it would be really, really important. Yes, it's going to be really soon. So I believe by the end of next week is our kind of the date we're shooting for. So in the maybe 7 to 10 day range. We're definitely going to try to get it as fast as we can. It's possible it might get delayed just a little bit. You never know what's going to happen, but yeah. Andrew asks, is the shooter gecko geared up at all? So it's actually very slightly geared down.
Yes, 1.06 to 1.
Very, very slightly. We printed a new V round belt pulley out of just some PLA, and it's held up really well, and it allows us to make the belts just a little tighter, and it increases our torque a little bit. A big thing that I'd like to improve if we were working on it more, would be to maybe gear it a little faster and turn down the max speed in code to something that you can always hit, no matter your battery voltage. Having your intake running or having your drivetrain running will also draw current, which will probably drop your battery voltage some. So having your motor able to hit the speed you're tuning it to all the time, I think would help a lot in the overall consistency of your shots. Yeah, it's... let's see. Lance Larson asked what the no gearbox motor part number adapter was. I'm pretty sure it's 1702-0032-0001. I think I have it in my hoodie pocket. Let me double check that real fast. Yep, 1702-0032-0001. And that has 4 mounting holes on it on the 25 mil pattern. 2 of those are 3 mil holes and 2 of those are 4 mil holes. So it's really important to mount it on the 3 mil holes and not the 4 mil holes. So it's very centered in that system. And I'm sure we will all have product insights and stuff to be able to show off exactly how that part is used in an assembly like this. Let's see. Do we have a 3D printed adapter that we can show a close-up of?
We have like half of one.
Yes. So.
Okay, I'm a 3 mil driver. I can pull this out.
Sure. It's not really one anymore. what happened to this one was that the screws on the hyper hub came loose, and it snapped kind of the end off. But it works pretty well as long as the hyper hub screws are tight all of the time.
To see, but
let's see here.
Yeah, it's just 12 recs. On the inside, there is a bore for that 17 tooth pinion. That's on the yellow jacket, and you can see there's a relief cut in the middle there just for some tolerance issues. And so normally that's clamped in a hyper hub right where the screws are, but if the screws come loose and the hyper tends to slide towards the end, then that's no longer really supported, and it can break pretty easily like that. So.
Yeah, so that's what happened there. Let's see. Andrew asks if he can get a $5.01 discount on the master kit so he can tell his coach that it's cheaper than the Tetrix kit. Definitely email marketing@goBILDA.com and see if they can do anything for you. They can probably figure something out, but that kit is also a really good deal already. It's definitely a lot cheaper than the parts individually, so that may be all the best you can do. Why Am I a Fool asks if the 8mm Rex part will be attached to the bare motor pinion. So it will be pressed onto that bare motor pinion, basically on...
Not the pinion, right?
It is the shaft. Okay, yeah. So it'll press onto the shaft and be held in just by that press fit, just like the pinion in your normal gearbox will be. So... that is an exciting part that we should be able to. I'm really glad that we'll be able to get it really fast. Most likely it'll come as a kit with the motor, with it already installed on the motor. It definitely can be tricky to get that pressed on just right. You definitely have to take the encoder off of the back of your motor, and having an arbor press is really huge in making sure that's pressed on really straight. If it's just a little bit off, it can definitely mess up the concentricity of that system, which is really huge in a flywheel. So most likely scenario, we're really not sure yet, unfortunately, but is that you'll be able to buy a motor with a 8-rex shaft coming right out of it. And it's definitely possible we'll be able to offer just the 8-rex shafting, but that's not been really decided yet. So definitely stay tuned, and as soon as we release that information will be out there. The adapter may be sold alongside, but it's really hard to say. Do you think a passive claw on the wobble is okay, or do you think a servo is really, or would you use a servo to really chomp down on it?
Honestly, I would probably just end up with 2 little bars at an angle, and then that way, if they're at a good enough angle, they'll just seat the cap in there. Honestly, if you're putting rings on it, which if you can already shoot in the high goal, not really worth it. But if you are, you should just use a servo and clamp around the tube.
Yeah.
But I think that just a passive little 2 hooks that are angled that'll keep it from moving around is just fine.
I think maybe a hook solution with a servo could be nice. Then your servo is not taking some of that load, but yeah, I don't really think it's necessary. If you get an angle at it, I think that'd be really nice.
And it would be especially important for those hooks to be spread apart enough so that you have a range for it to bounce around as well. Because this is, if you miss, it's just kind of over really. You hit it, and it's a wobble goal. It wobbles. That's about all there is to it.
Yes.
Lacking on error room, that one is.
Can we show a close-up of the linkage for the wobble goal mech? Yeah, for sure. So let's see here. It is a speed servo, which I like. I mean, I think we could nickname the linkage servo at this point. They are my favorite servos for linkages. So it's got a double servo arm with a longer beam mounted on it, and it just has a threaded rod linkage system. So it can rotate a fairly small amount of its total rotation and get the full throw of that linear slide out of it. Really, to get this, I had 2 really long beams, and I just played with the overall length until I got it to a point where I liked it at. And at this point, I'm pretty happy with how it turned out. So I got this bar, which is exactly the length that I knew I needed, and then I replaced this end with a linkage. That allows you to really tighten down these screws, and the plastic actually rotates around that steel ball instead of the having to rely on aluminum, twisting on aluminum. So I like it. I'm really happy with how this system went. This whole mechanism was honestly kind of an excuse for me to play with linkages. You can see it doing something that's really bad there. If it overextends past, you kind of have this annoyingly uncontrolled movement. So I would add an end stop to make sure it couldn't go back past. But if it's within its normal operating range, it's really darn fast and it's a lot of fun. Linkages are really, really fun to be able to play with, and beams are a great way to do that really easily. Is there any scenario which a high-level team will score rings on the wobble goal? Do you have any thoughts on how you do it?
Strategically, it kind of makes sense if you're like really trying to ring starve somebody. Like, if that's your, yes, but actually no, because like, if you think about it, the only reason I see really is to get rings out of the playing field as fast as possible. If your opponent's strategy is to keep just scoring high goals and then get the power shots, then yes, but you're still scoring less points than you would be just like playing a little bit of defense while getting 3 rings and shooting them in the high goal. It's if you can only shoot in mid goal as a higher level team, yes, that makes a lot of sense because you're scoring more points per ring. But it's also like it'll require most likely a separate mechanism, and yeah, in my mind I've just been it seems just not worth it.
Yeah, I've definitely been wrong about stuff like this before, so I definitely could be wrong on this, but I think I'm in that camp too, where I just don't feel like it's really worth it. I think for me the end game priority is super shots and then getting this outside of the field, and then just shooting more rings into high goal if you have time. That seems like it's going to be the order of operations for a lot of good teams. I don't think I have a whole lot else to talk about this robot. It's been a lot of thinking about and a lot of doing. What are your final thoughts about it?
Well, I actually did want to talk about something really quick before we wrap up, final thoughts. But if you've been following the build process, which I'm sure a lot of you have, we've been using this clamping mount and go tube or go rail trick so much on this robot. And this is so fantastic because a lot of times I feel like with kits like this, you sort of feel like you're locked to the angles that certain parts give you. Like, you might be locked to this angle, or you'd be locked to a 45, like on this mount. But with this go rail here, you have all this mounting space. You can throw those pattern adapters in there for a better clamp on your clamping mounts. And you can just go any angle, and especially if you mount these to go rail here too, you can have any height, any width on the intake, and yeah, it's just fantastic. That same thing is used on the shooter down below. It's mounted with those 32 mil clamping mounts, and it makes it super easy to get your angle really dialed, and yeah, you're not locked to any specific angle, and you don't have to like shim plates in weird ways. So yeah, it's really fantastic, I'd say.
Yeah, it just gives you a lot of variability to tune everything after you build it. That's one of my favorite things about clamping mounts in goBILDA, is that they give you whatever angle you need to find.
Exactly.
We also used a lot of beams on this robot.
Yeah.
For somebody who doesn't normally use beams a whole lot in their builds, once you get into the smaller scale robot mechanisms, that's where they really come in handy. So we used a lot of shaft beams and square beams and some L beams, which I feel like are some of the least used ones.
Beams are so good, dude.
Mm-hmm.
So good.
And
This whole bottom roller is just beams.
yeah,
It's very nice.
so we used them a lot, and they're great to kind of fill in small spaces where you might otherwise have to go fabricate a whole new parts to fill in that space.
Mm-hmm.
All right, it sounds like all of our Gecko wheel coupons were used up, so that was really exciting. You can still grab some more disc wheels. Those ended up being a lot nicer to interact with the rings than I expected.
Yeah.
So that was a great suggestion from a great member of our chat. Let's grab a couple more questions, and then we'll probably leave you guys and head on out for this week. Let's see here. Any ideas on changing the angle of your shot on the fly on the robot?
Pretty simple. Well, less simple than it seems. You know, our shooter is already mounted on an axle. But this axle is really not in an ideal location to pivot the whole shooter. I think you'd really want an axle more towards the base of where your ring sets, like the rear part of where your ring would set, and then a servo linkage here. Maybe even a servo linkage that has a lot of mechanical advantage, and maybe has a bit more resistance in the system. Not bearings, but maybe like a more solid bushing or something. That way it's not so free, because I can see when you're changing your angle on the fly, your servo can jitter a little bit, and if it's constantly holding up that shooter right, it's going to be changing that angle very, very slightly. So yeah, it's definitely tough. 2 servos with linkages would be good. Just, yeah, you have to be so careful with what your angle is at.
It's definitely kind of on that fine scale. But it seems like it might be worth it for your high-level teams who are maybe looking at the targets with CV or another method.
Definitely.
You may be able to adjust your angle depending on how far away you are to always make sure you're in that high goal. Let's see. Dan says in the chat, do you think having the shooter higher up on the robot so the rings come out more flat would be better, or not worth having a high center of gravity?
Yes, I think so. Obviously, for this, it was nice to have it really low because we didn't have to figure out exactly how to get the rings up at such an angle or make a deployable intake or something along those lines. But yeah, I'd say definitely that'll give you a huge or a larger air room, or a lot larger air room for the high goal, definitely. And probably also better for power shots as well. Well, actually no, it might not be better, because if you have more of an angle for the power shot, then you'll have more surface area to hit it. I don't know. It's tough. Definitely for high goal though, that's flatter flight is absolutely better.
Yes. It's definitely more difficult to get rings up. I think that's going to be a fun... There's kind of definitely a trade-off there. You may have a slower intake system, but better shots. So it's really interesting, kind of the trade-offs that you see in a lot of those designs.
It's also difficult to get from an intake to get your ring. If it's at an angle like this, that's going to be difficult to really control to get it, to get it much higher than that, because the more slope, the more you have to deal with gravity wanting to pull this end down when it loads into your hopper. I don't know if you'd be using, a gravity indexer or, a different type of indexer, or maybe like the Robot in 3 Hours video where it was just a straight ramp and they indexed by having one here, and one here. But, it's just, it's definitely a challenge.
All right. with that, I think that's really a lot of the things we can talk about this robot. We'll definitely make sure to highlight these 4 streams and make sure you can always reference back to them. If you have any questions, you want up-close pictures or all of that stuff, definitely shoot us an email over to tech@goBILDA.com. You can always give us a call and ask to walk through stuff and run ideas past us. And overall, we really just love being here to help you guys. So however we can do that, we really love to. Thank you so much, Jacob from Recharged Green, I guess formerly, for coming down from Iowa to build our robot with us. Thanks to Luke behind the scenes. He did a lot with the robot this year. And this year, I'm already talking like an FTC team. These last few days, and really helped us out with it. And huge thanks to FTC Oklahoma for lending us their field and letting us use these game elements before we could have had a chance to get our own field in. With that, see you guys later.